Okay, so today we are going to look at your homework from last night, so go ahead and get that out. As I am going through and looking at your homework when you end up submitting it, or for students who have already submitted it, make sure you look at those comments because I will be leaving comments on your assignment very detailed, so make sure you look at those to help you. And then we are going to continue graphing quadratic functions today. We are going to talk a little bit about min and max values and how to determine the min and max value of a quadratic function. For homework tonight, it's a practice worksheet. However, you are given another outline like you were last night of the homework, so that is on Google Classroom for you. And we'll look at that at the end. I can show you it real quick. All right, so go ahead and get that homework out from last night. I want to look at number 9 to start with you. So this problem was y equals negative 2x squared. Our first thing that we're finding is the axis of symmetry. Faith, can you tell me how we are finding the axis of symmetry?
You can do negative b over 2a.
Yes. Now make sure you're writing that as x equals. So here, our a is negative 2, our b is 0, and our c is 0. So here we end up having x equals negative 0 over 2 times negative 2. We know that that's just going to be 0. We have a 0 in the numerator. So our axis of symmetry here is x equals 0. The axis of symmetry is not just 0. It's x equals 0. So then I'm automatically going to go over to my graph and show that dashed line at x equals 0. Next, our vertex. We're plugging in x equals 0 into our function. So we have negative 2 times 0 squared. We end up getting 0. So our vertex is 0, 0. And that point falls right on that axis of symmetry line. So make sure you are drawing your axis of symmetry. It is a part of the graph. On last night's homework, I saw a lot of people didn't have this axis of symmetry drawn. You must draw it. It is a part of the graph. First thing I would do once I find that axis of symmetry, I'd go ahead and draw that dashed line. And your vertex falls right on that axis of symmetry. Next, for our y-intercept, we know we are setting x equal to 0. Well, here, we're just plugging in 0 there, and we know we're going to get 0. Our y-intercept, again, is not just 0. Our intercepts we have to write as points, as ordered pairs. Make sure you're writing our intercepts as ordered pairs. That's something we've been doing. And lastly, when we're setting y equal to 0, we get 0 equals negative 2x squared. We can divide both sides by negative 2. We get x squared equals 0, which is just x equals 0, which we have to write that again as an ordered pair. So make sure your notation is, you're being specific with your notation and precise. Your axis of symmetry is x equals, and your intercepts are ordered pairs. Okay, so here we only have that point at 0, 0. So, which I saw what was great on a lot of the homework. Let's just make a quick t-chart. Find some other points, because all we have is that 0, 0 point. So we can go ahead and pick our negative 2, 0, 1, and 2. And when you end up doing that math, these are the points you will get. And then we can draw the points or plot the points on our graph. and draw our curve. And that's what you should have done for number 7 right above it as well. You would have only gotten that origin point from the intercepts and the vertex. Questions on the first page for how I did number 9. All right. I want to also look at number 22, which is on the next page. So my first step is always just to rewrite what my A, B, and C are so I don't miss any signs, negative signs. We know our axis of symmetry is x equals negative b over 2a. I'm just rewriting it. So we have negative b, which is negative 6, over 2a. We end up getting a positive 6 in the numerator with the double negatives. So this is 1. So our axis of symmetry is x equals 1. I'm going to go right over to my graph and draw that axis of symmetry at x equals 1. Our vertex, we're plugging in 1 for x. This ends up getting us 1. 1 squared is 1, 3 times 1 is 3, minus 6 is negative 3, plus 4 is 1. So our vertex is 1, 1. Again, a point, an ordered pair. Our intercepts, setting the opposite variable equal to 0. Here we have x being 0, and we end up with just that y is 4. This turns to 0, this turns to 0, we're just left with y equaling 4. So our y-intercept is 0, 4, written as an ordered pair. Lastly, for our x-intercept, we're setting y equal to 0. So we have this quadratic, and it's equaling 0. We saw we can't factor easily, so let's use the quadratic formula. We have x equals negative b. We have that double negative here, plus or minus square root b squared minus 4ac all over 2a. This gives us 6 plus or minus. Inside the square root, we have 36 all over 6. From my minus 48. And we can see in here, we're getting a negative under that square root. 36 minus 48 will give us a negative 8. When we have a negative under the square root, we know we have an imaginary number. This is imaginary. When we get an imaginary under that square root, it doesn't exist on a graph like this. Therefore, we have no x-intercepts. There will be none. When we're graphing, we're dealing with all real numbers. We can't just throw an imaginary number in there for graphing. questions on how I got none for the x-intercepts? Okay, so we have our points, and let's plot them. We have 1, 1, and 0, 4. By using the axis of symmetry, I can plot the point 2, 4, and I can see that my graph goes up. And here you can see our graph isn't going to cross the x-axis. That's why we have no x-intercepts. So when you have none as the x-intercepts, your graph better not go through that x-axis. Questions on this one? Okay, we're gonna do more examples today, and you'll practice more for homework. If we have time at the end of class, I can come back and do another problem. All right, so let's head over to our notes now on page 30. It says minimum and maximum values at the top. I'll give you a second to go ahead and pull that up. So, minimum and maximum values for a quadratic function. It is the vertex's y coordinate that will be the min or max value. So the vertex's y coordinate is the minimum value of the function if a is greater than 0. When a is greater than 0, we know that our graph is opening up. Therefore, we have that point at the bottom, that's a minimum. So when our graph is opening up, we have a minimum value, which you can see right here. So when a is positive, we have a minimum value. And if we have a maximum value, that means that a is less than 0. A is negative, which means that our parabola is opening down, which gives us that maximum value. The vertex is where this point is. Can we have both a min and max? What do we think? Can we have both a min and a max value? Grace, what do you think? Can we have both a min and a max value?
I know, because it can only go one way.
Yeah, so we only have one vertex with parabolas, and it's either going to be a min or a max. Good. All right. So now we are going to use algebra to find this min or max value. And the value is the y coordinate. So they're saying tell whether the function y equals negative 3x squared plus 12x minus 6 has a minimum value or a maximum value. We'll pause right there. Does this function have a min or max? We don't have to worry about the value yet, but do we know whether it's going to be a min or a max value? What is our a value? Valeria, what is our a value for this function here?
-6.
So our quadratic function is y equals ax squared plus bx plus c.
-3.
Yeah, -3. So our a is -3, which is negative. So do you think we're going to have a min or a max value?
Max.
Yeah, max. So we know we're going to have a max. Now we want to find it. Well, how did we find the vertex? We know it's going to be the vertex. How did we find that?
we solved the quadratic equation?
That would be to find intercepts. Ella or Jaden, go ahead. What was our step to find the vertex?
Sorry, no, it's,
Okay.
don't we have to find the line of symmetry first in order to find the point?
Yes, we have to get that axis of symmetry. How did we do that, Jaden?
We take x equals -b over 2a.
Awesome. So we have x equals -12 over 2 times -3. So we get -12 over -6, which gives us 2. Now, Jaden, what are we doing with this x equals 2?
You plug it in for all the x values in the original equation.
Yeah, good. So we have -3. Now we're plugging in 2's for our x's. I'll give you a few seconds to find that value. Eva R, when you get this value, let me know what you get.
Yeah, sorry, give me 1 second.
You're good. No rush.
Is it +6?
Yeah. Awesome. Good. So we know our vertex is 2, 6. But the vertex isn't the min or max value. We look above, the vertex's y coordinate is what the min or max value is. So we know we're having a max here, but our max value is 6. Because think about it. If we're looking at this graph here, we know our vertex is at 1, 1, but the value of the max, we would go over to that 1. We wouldn't say the max is at the vertex. We'd say it's at 1 because we can see it's at 1. That's how high the graph is going, to 1. So we would say the maximum value is y equals 6. And it's y equals, we're talking about our y coordinate. We wouldn't just say the maximum value 6. 6 what? We have to be specific. It's y equals 6. Questions? All right, so now let's practice more with graphing right below. So these problems weren't as nice as how the homework problems set everything up for you, but that's okay. We have space to do that. So we know, or they're even telling us to find the axis of symmetry, vertex, and intercepts. We know how to find the axis. We know how to do this. So I will give you a few minutes to go through and try this problem on your own. And then we're going to go through it together. Be careful of your signs. Be careful of your notation. It's okay if you're not done. But Jordan, can you tell me how you found the axis of symmetry?
I did -6/2 times 2.
Awesome. I love that. One thing I want to make sure that you are saying and writing down is x equals -6/2 times 2. Very important to have that notation, x equals. So then what did you get as your axis of symmetry?
I got -3/2 or -1.5.
Awesome. Yeah, we'll keep it as fractions. X equals -3/2. Awesome. Lacey, can you tell me how you got the vertex?
So I just put the -1.5 into the equation as x, and then I ended up with -1.5 again.
Awesome. So we're plugging that -3/2 into our quadratic function for x, and we do end up getting -3/2. So our vertex is -3/2, -3/2. Awesome. Next are intercepts. Riley, how did you find the x-intercept?
I made y equals 0. So I did 0 equals 2x squared plus 6x plus 3.
Awesome. And then what did you do after that?
I didn't finish it yet, but I
Okay.
think
I'll
we
give
just-
everyone another few seconds to finish it. But what were you saying? What were you thinking?
would you just subtract the 3?
So if you subtracted the 3, and then what are you doing after that?
Or would you just factor?
So we would have to factor this in some way. So can we easily factor this? Can we see that there's an easy factor?
Yeah, I think so.
So with AC method, there'd have to be factors of 6 that add to 6. Does that make sense?
Yeah.
Are there any factors of 6 that add to 6?
Yeah, 3.
3 and what?
3.
So 3 and 3 will be factors of 9.
Wait.
It's okay. So there are no easy factors for this one. So what would you think to do next?
The quadratic formula.
Yeah, that's what we would do here. So I'll give everyone another minute to finish that quadratic formula if you have not already. So when you're finished the quadratic formula, you should end up getting -6 plus or minus 2√3/4, or you could split that up into 2 different fractions. And then you would plug both of those into your calculator to find the x-intercepts. Did anyone get that far? So we'd plug in -3/2 plus √3/2 and then -3/2 minus √3/2. So go ahead, Jaden, did you get those values?
Sorry, I didn't get it, but I just had a question about it. So are you not simplifying there? Like, or is that the 3/2? Are you just you're just splitting that up, right?
Yep, that's just splitting the fraction up. So that's -6 divided by 4, which then I simplified to -3/2. And then
Oh, okay.
and then on the right hand side, when I split that up, I would get 2√3/4 for this half, which then I can make √3/2 when I simplify that to 2 and 4.
Okay, thank you.
You're welcome. So once you plug those values into your calculator, you should get -0.63, then -2.38. And those are x-intercepts, so our y is 0. And then lastly, we would find our y-intercept, which we know we're setting x equal to 0. Annabelle, did you get your y-intercept?
I got 0, 3.
Yeah, good. So now we have all this data. So now let's graph it. I'm going to go to my x equals -3/2. And I'm going to draw that axis of symmetry. And then also plot our -3/2, -3/2 point vertex. We have our x-intercepts. We can draw our curve. We can see that our parabola is opening up. And that's because our a value is greater than 0. So here, do we have a min or a max value? Ella, do we have a min or a max value here?
We have a minimum value.
Yeah, and what is that minimum value?
Y equals -3/2.
Yeah. Awesome. Good. Questions on this one? So a lot that goes into these problems. It's very important to be careful with your negative signs. Don't miss any.
Miss Carp,
Yeah.
whenever you were simplifying for the x-intercept, so after you had -6 plus or minus 2 in the square root of 3/4, how did you break that apart further?
Yeah, this is what Jaden was asking too. I'll bring it down here. So we have x equals -6. So I am breaking this up like that. So we have -6/4 plus or minus 2√3/4. Breaking that fraction up into 2 parts. So then I know that -6/4 is -3/2. And then I can cancel this 2, and then we'd just be left with 2 in the denominator.
So in my mind, I guess, why wouldn't that be 1/2?
Oh, yeah, that's fine. If you want to make that 1/2 and multiply it by √3, that's fine. But since it's just a 1, you could just put that √3 in the numerator.
Okay, so then if you left it like 1/2 square root of 3, would you have to multiply the 1/2 into the 3 square root of 3? Or could you leave it like that?
I would bring it to the root 3 over 2.
Okay,
Yeah.
thank you.
You're welcome. I'm sure other people have that same question. All right, so now let's do number 2 right next to it. Let's do it all over again. We'll start with the axis of symmetry, vertex, and our intercepts. So I'll give you a few minutes to start this problem. Right off the bat, I would just write above it what my A, B, and C are. Totally okay if you're not done. Helene, can you tell me what you got as your axis of symmetry?
I got -2.
Awesome. And Madison, can you tell me what you got as your vertex?
I didn't get there yet. Wait, hold on.
Oh, sorry. I'll give everyone another minute.
I got 6.
Awesome. So then our vertex is -2, 6. I'll give everyone a little bit more time for the intercepts. Malachi, did you get the x-intercept? What about Gabby Snyder?
No, I didn't.
What did you get?
I didn't get anything yet.
Oh, all right. So let's do it together. So were you able to easily factor this in any way? Factors of 2 that add, or factors of -2 that add to -4? No, there aren't any. So Gabby Snyder, what do you think we should do?
Put it into the quadratic formula.
Yeah. So then you should end up getting x equals -2 plus or minus √6. When you plug that in your calculator, you will end up getting -4.50 and 0.50 as our x-intercepts. Then I'm going to do our y-intercept right back here. We're setting x equal to 0. Ava M, what did you get as your y-intercept?
I got 0, 2.
Awesome. Plug in 0 for our x's, and we end up getting 2. Questions on any of the computations I did there for finding any of the parts? First thing I'm going to do is put that axis of symmetry at x of -2. Oh, we can see that our scale is a little different here. Very important to look at that. Our x of -2 is right there because we can see those first, each unit is 2. So our -2 is here. So -2, 6. Our vertex is right there. Our y-intercept and our x-intercepts. What other point can I plot by using the axis of symmetry here? Gabby Soul, what other point can I plot looking at the axis of symmetry? Using the axis of symmetry. What about Julia?
You would do one, it would be -2, 1.
So I see, yes, it's going to be right here, but that point is technically -4, 2, just because of the scale. But I see what you mean. Yeah, I knew what you meant. And then we can draw our curve. It's okay, Gabby. All right. Questions on this one? All right. So we have 2 minutes left in class. Your homework for tonight is right here. It is an outline again of the problems that you have. So for the first 5, you're telling whether it opens up or down, what the axis of symmetry is, the vertex, and max or min. We did all of those in class today, so nothing should be new here. And then again, you're going to practice graphing. And lastly, you have 1 word problem. It's easier than it looks. So there's about a minute left. You are free to go. If you have questions, please stay. If you have not handed in your homework from last night, please do so.